Okay. No?
Myself.
No, okay. Right, so potential divider.
How many points?
I'll check for you.
If this too much, don't show me.
One question only.
Wow.
Just one question. Yeah, just one. It's not as bad as it looks, I promise.
I want to say something, but it's hard to translate to English.
Don't worry, I understand what you want to say. Okay. So did you write the title down? Potential divider. Do you know this word in English?
No.
No.
Okay, right. Right, potential divider. Okay, so draw this circuit for me. We have a cell here with a voltage, and then a voltmeter here. What?
Just like
They trap.
just the trap and then another trap. Jump.
It's a trap?
Yes, physics.
It's a physics trap? Okay. Right, draw this.
Something like hard to say.
Okay,
Thank you.
you can send me a picture. Right.
I can send you Chinese word and you can translate in Google.
I will do that later, yes.
Yes, you check your email yesterday.
I'll check it. I did, I promised I would. I did.
Yes, this is the only time.
Yes.
I'm very happy.
This is the first and last time.
Oh.
So this circuit is called a potential divider. This circuit. Okay, did you draw this?
No.
Not yet? Right, so have a look at the two resistors. The R2 is fixed, and the R1, you can change it. Yeah? V1 is, this is voltage 1 and voltage 2. So V1 is the voltage from your cell. And V out, V2, is the voltage you measure. So what's happening here, let me see if I got it on my laptop here. Yeah. So this laptop here uses input 220 volts. Yeah, 220. But here at the end, this is not 220 that comes out, because the laptop here, it only needs like 12. You understand?
Yeah.
So there are many ways to change the voltage. This is one way you can change the voltage. So this side here, this is like the voltage that comes in, and then this here is like the circuit, and this piece here is up the top, is the voltage that comes out from the circuit. And usually what you're doing is you are changing the voltage here to a different number here. Now, this is not actually what happens, but it's just the idea. Yes?
Nothing.
Do you need to move?
No.
Are you sure? Okay.
Something easy.
All that next semester. But the concept is we need a way to change voltage. Yeah. Okay. You drew this? Yeah.
Is it the same like step down?
No, see, that's something different actually, which we'll do next semester. Yeah. So by using the loop rule, Kirchhoff's loop rule. Yes. Okay. Huh? Say again?
No.
No? Okay. Let's use Kirchhoff's loop rule. So if I start here, what's the voltage here? V in. And then I go around in the loop, minus I R1, minus I R2, equal 0. So that's the loop rule. Yes? Okay. Next, we can rewrite that to make I equals V in over R1 plus R2. That makes sense, doesn't it? Yes, makes sense? Yeah. Okay. But if I look at this rule, do you remember the triangle VIR? What does V equal? IR. So the voltage here should equal I multiplied by R2. So you can say V out equals I multiplied by R2. But you have a formula for I on the previous line. So I can put this in here for I, and I make this result. Yeah. Here, the V equals IR. So V out equals IR. But I know the I from here. So if I put this here for I make this. So this is our formula for potential divider. It's not difficult to prove. You just need Kirchhoff's loop rule and you need the VIR triangle. Okay, continue? Yep. So the potential divider allows for an input voltage to be reduced. The output voltage can be found by the formula here. So this is the key formula for this lesson. Yeah? Me too, actually, and I didn't get time to get my coffee. Because
Do you have your breakfast?
I had my breakfast at least.
What's your breakfast today?
You know what it is. It's the same thing every day. Oatmeal. Yeah.
Every day?
Every day.
Did you do it yourself?
Of course. My wife's asleep at 7 o'clock in the morning. Yeah. Okay, so we have our formula here for output voltage. Yep. Now, let's continue. Oh, so Patrick, you were talking about step up and step down transformer, which we'll do in semester 2. It's a similar idea, except what's important here is the potential divider only reduces the voltage. It makes the voltage smaller. So with what you're talking about in next semester, you can actually go increase or decrease. Yeah, yeah.
Next semester we should choose one subject in physics.
No. In next semester, we have 3 more. We do 6 in total.
6 in total.
Yeah, and yeah, have to do it all.
Yeah.
Yeah. Okay, next now. Huh?
Doesn't matter, I have to do everything.
Do everything, yeah. Well, in the exam you don't have to do every question, so you have a choice. You do, I think you do 3 questions from 6, I think. Yeah. Yeah. Okay. Right. So here is our example. How many questions have I got? Just the one. Nice.
We can finish earlier?
No, because we started late because of me.
You can stay here.
Yeah, I can stay and let you go, yeah. Okay, so a circuit requires only 11 volts, however the mains provides 220 volts. You have a 10 milliamp and an X milliamp resistor. Draw the correct potential divider circuit. Find the value of X. How much current is coming out of the divider? Okay, so write that down and then we'll do it now. Yeah.
No.
Huh?
No.
Got this? You wrote all of this down? Okay.
Not yet.
What?
That's fine.
What day is it?
Today is Wednesday. And the date?
This is
23rd.
Mm.
2 more
Yes,
days
yes.
for Batman. Just 2 more days. Yes. Are you all going to see it together?
No, not together.
Not together?
Not together.
No?
we could if we wanted to.
But you don't want to. Okay, so let's draw this problem now. So what we have is a voltage of 220. And here we have... You okay? Yeah. Here we have a resistance and here we have a resistance. How big is the first resistance? It's 10. Now because the X is here, I'm going to call this one that we can change the X. And this one here will be the... Now this is X milliamps, or milliohms. So if you want, that's X.
How I know it can change?
Well, for the potential divider, you have 2 resistors. One here which is fixed, and the one outside here is one you can change. So you can make it bigger or smaller.
Is this semi thing?
Yeah, it's always like this. You can usually change this one. Okay, but because X is in milliamps, if you want you can say it's X over 1,000, because I said in the question it's X milliamps. I keep saying amps. Milliohms.
But
And this...
another one,
10 milliohms as well, so this would be
10 over 1,000.
10 over 1,000. Yeah. Right, now what voltage do you want here? Oh, well, the first question is draw, second is find the X. What voltage do you want on the output?
It's 11.
You want 11. So if I use my formula, V out must equal R2 over R1 plus R2 times V in. I get 11 must equal 0.01 over X over 1,000 plus 0.01 times 220.
Next question. B.
Yeah. I can multiply the top and bottom by 1,000 and I would get 10 over X plus 10 times 220.
Why is it V0?
V out.
Oh.
Yeah. So if I solve this, I get x equals 190, I think. Let's double check that. Yeah, x is 190. Yeah? Okay, that was part B.
Hold on.
Yeah, but I'll write over here. Part C is what's the current, I. So what formula could I use? I could use V equals I R. So I equals V over R. So I would equal 220 over R, which would be 0.190 plus 0.010, which equals a large number.
Wait, which is the divider?
The whole circuit is called the divider. Yeah.
I think this 190 is ohms, 190 ohms, so.
Oh, sorry, that's not
Yeah.
milliohms. Sorry.
It's 190 ohms.
It's 190 ohms.
Yeah, because we converted in,
Yeah.
And
Yeah, we just.
Because they changed it to
we
ohm.
changed it before, so it should be.
something feels wrong. Something feels wrong. No, the x here is milli. Like sorry, I see my mistake. I think. No. Oh, x is 190. Oh no, I'm confused. Maybe I shouldn't have used milli ohms. Yes.
The question B,
Yes.
do you multiply 1000?
Top and bottom.
I think it changed the answer, because you multiply.
But I multiplied the top and bottom
Yeah.
by 1000. Should be okay.
Is it affect the answer or?
No, I shouldn't. I could keep it like this. I should still get 190.
So do you divide 200 to 1000?
No, I can just do it here, top and bottom. Something went wrong.
Why is the answer wrong?
Well, I just don't feel like it should be that big.
Everything is possible.
True, everything is possible. You know, Batman could win against Superman, so
Yeah.
no, everything is possible. Yeah.
It's just 1.16 amperes. Is that a lot?
No, but I don't know.
Actually, maybe you should be using the V out here in spite of 220. But out of the
Oh,
divider,
hang on. Oh yes. Coming out of the divider. That's the problem. I should use V out. Because I wanted, no sorry, I wasn't clear. I wanted the current coming out.
I thought you said the divider is the whole thing.
Yeah. So like this room is the whole room, and I said coming out of the room means, you know. So coming out, what was my voltage? 11, is it? 11 over 0.19 plus 0.01. So what do we get here? That's a bit more reasonable. 55 amps. Still big though, yeah. Okay, I want to do another example though, when you're ready.
Wait, why is it 0.19? Isn't it back to 190?
Oh, for goodness sake, yes, so sorry, I'm so hungry now. 11 over... No, it was, no. The resistance here is X over 1000. So it was 0.190. Yeah, no, that was right. Don't worry me. 55 was right. It was right. Yeah. Here, if you look here, the resistance is 190 over 1000 ohms. or if you want, that's 190 milliohms. Maybe.
But here x equal 190 is ohms, not million.
No, this is milliohms.
But you change to you change it already. At first time you change to.
No, here x is still milliohms. But if I divide by 1,000, then this fraction here becomes ohms. But the x part is still milliohms.
This whole thing is ohms.
Yes.
Only x.
Yes. Okay, we're good now, yes? Right, now, of course, I need to add one extra part to this question. Can I go down? So, let's draw this. So, this is our situation. Here we have, how much? 220. Here we have 0. Well, we'll put in milliohms. 10 milliohms. The one beside it? 190 milliohms. So what voltage do we get here? We said it should be 11 volts. Correct? Yeah? Okay. So now, here's my plug. So I plug this in, 220, and this here should be 11. Now I connect it to my laptop. So I'll draw my laptop. And let's say my laptop is here, and its resistance is 2 ohms, for example. It's probably more than 2. Will the voltage still be 11 for the laptop? No, because resistance has changed. So now in this picture here, R1 is still 190 milliohms. But if I want the voltage, this one. If I want the voltage now, let me draw a little voltmeter. The R2 is not 10 milliamps, is it? Because the resistance has increased. How can I get the total resistance now? I could say 1 over R2 equals 1 over 0.010 plus 1 over 2. So this means R2 will equal haven't said it yet. Oh, sorry, no. Yeah, that's right, yeah. So 1 over R2 would equal 201 over 2. So this means R2 will be 1 over this, which is 9.95 milliohms.
Really?
Yeah, because I got 0, my calculator got 0.
R is changed to R2.
This here, ohms. This here, ohms. This here, ohms. Yeah, but R2 will be 2 over 201, which is very small, so I just converted into milliohms here. Can you calculate V out for me now? So it won't be 11 anymore because the resistance has changed, it's increased. Calculate it for me. Let's see. ohms.
What
When,
is
Vn is 220. Get an answer? I think you're, yeah, 10 point,
9,477.
yeah, 10.95 volts. So, even though we connected an external resistance, did the output voltage change much? Did we get the 11 volts that we wanted? Not quite. We nearly got 11 volts. We got 10.95. Nearly the same. Can anybody tell me why do they think that the voltage, I still got nearly my 11 volts even though the resistance changed? Why? Yeah? I'll say that again. Previously, on the potential divider, we made the resistance here 190 milliohms so that we could make a voltage here of 11. Then when we connect the laptop, we don't get a voltage of 11, the voltage drops a bit. The output voltage we got was nearly 11, 10.95, which is good enough. So why did it not matter too much that I had the laptop connected or not connected? What is the reason in the calculation that meant, oh, I still got what I wanted nearly? Any ideas?
No.
The reason is,
The
Another
VG is the
combination
same.
no,
R1, R2 in thing.
Oh, because it's
Nothing.
connected in parallel.
no, well, almost.
It's almost same like the internal
That's in
resistance
parallel.
and.
That's not in parallel. Well, it's in parallel here,
Yeah.
in series here.
Total.
The reason is, these two are very small. So if you look at this calculation for the total resistance, this number here is 1 divided by a small number. This will be really big. This here, 1 divided by a big number, this will be really small. However, that's for 1 over R. You have to flip it to get R. So in other words, the big parts don't matter and the smaller parts matter. Which means that the big resistance is more important than the small resistance. Notice how this answer here, I got, what answer did I get here? 0. Sorry, I said this backwards. Let me repeat that again.
There, 9.99.
Yeah, let me repeat this again. Sorry, but I can't see. This here is small, this here is big. So that means in total this piece is big and this one is small. So when you add them together, you only care about really this piece. It's almost like this one's not important. So if I have 1 over R2 equals 1 over this, then what does R2 equal? It's about this. So this number here was 9.95 milliohms. That's nearly the same as 10. So my point is, by making these small in the potential divider, it doesn't really matter about this one being big. Yeah. Now, the reason that you might want to change this is because we don't have 11 for the laptop. So what do you think? Should I make this one bigger or should I make it smaller?
Smaller.
Smaller.
Bigger.
Which?
Middle.
No, because
Well, think about the formula for output. It's R2 over R1 plus R2. Is this R1 or R2? R1. You want to make it bigger, and the R1 is down below.
so
Smaller.
bigger the bigger the number.
Bigger.
No.
The smaller the bigger the number.
No, think. You have a fraction, R2 on the top, R1 plus R2 on the bottom. You can only change R1, yes? So can you change the top or can you change the bottom?
To make the voltage bigger, is it?
No, just answer my questions, right? Can you change the top or the bottom? The bottom, because that's where the R1 is. Do you want the voltage output to be bigger or smaller? Bigger. So do you want your fraction to be bigger or smaller? Bigger. So the bottom you want smaller. So this one you should make it smaller. So if you decrease this a little, you can get the 11 volts back. So that's what I mean, you like to change this one. We're good? Great. Okay. Take a picture. You got this? I'll upload the video later today as well. Okay. Let me can I close this? Yes? Not enough power. There we go. Right. Wait, we have no lessons tomorrow? You have what tomorrow? Do we?
What?
Since when? Show me your timetable.
Yeah.
Nobody told me about this.
That's September timetable.
Show me. Oh,
Oh, it's not in September.
that's not.
Not in September.
I see.
Yeah,
I see tree physics.
4.
4? When? What times?
It's 10 to 12.
Oh, I see.
Yeah.
10 o'clock, 11 o'clock.
Yeah, and in
Three-
the end 3 to 5.
Well, we just like the normal timetable.
Yeah.
No, not like normal. We don't normally have 4 hours on Thursday.
You can check.
I checked, I saw it on hers, yeah.